Hi, this is Lakshmi Priya. In this presentation, we are going to discuss the working of monostable multivibrator using 555 timer. So we have already discussed the working of astable multivibrator in our previous video. Here we are going to discuss about the monostable multivibrator, and we know that the monostable multivibrator is a one-shot multivibrator, which means the monostable multivibrator have only one stable state. So it remains in its stable state until the trigger pulse is given. So this pin number 2 is connected to the triggering input. When this triggering is given, so the multivibrator momentarily goes from its stable state to unstable state, and after the few seconds it will again come back to the stable state, and the time where the multivibrator remains in one state, either high or low, is determined by these resistors and capacitor connected to the circuit. Here is the internal block diagram of monostable multivibrator using IC 555 timer. So this is the potential divider circuit. So the value VCC is equally divided at this 3 terminal. Here we will get 2 by 3 VCC. So here it is 1 by 3 VCC and 0 here, because the value of the resistors are equal. So initially there is no input and no output. So the output here is 0. So the operation starts when the negative going trigger is applied to the pin number 2. So this is given as the input to the negative terminal of the lower comparator. So the comparator compares this voltage. So at that time, so this triggering voltage is the negative going trigger. So when this voltage goes below this 1 by 3 VCC, so the lower comparator will turn on. So the output of the lower comparator is 1. So this is given as the input to the RS flip-flop set input. So whenever this set is 1, so the output Q here is 1 and Q bar is 0. So this inverting input Q bar drives this transistor. So when this Q bar is 0, so this transistor acts as a open switch. So there is no path here. So at that time, so this capacitor starts charging towards this VCC through this resistance R. So when the voltage of the capacitor goes above this 2 by 3 VCC, so at that time, so the upper comparator output goes high. So this is given as the input to the R terminal. So whenever the reset input is 1, so the output Q here is 0 and the Q bar output is 1. So whenever this Q bar is 1, so this transistor acts as a short circuit. So this capacitor starts discharging through this path. So in that way, so the output of the monostable multivibrator momentarily goes high and again it will come back to the stable state. So when we come to the derivation part, so we know that the voltage across the capacitor is, that is VC equal to VCC into 1 minus e power minus t by RC. So in the capacitor, so the voltage will be rises exponentially, and the on time is the charging time of the capacitor from 0 to 2 by 3 VCC. So here we can say that the capacitor charged from 0 to 2 by 3 VCC, the maximum of 2 by 3 VCC. So here we are substituting 2 by 3 VCC, that is equal to VCC into 1 minus e power minus t by RC. So this VCC term will cancel, so on both sides, and when we simplify these equations, we will get 1 by 3 equal to e power minus t by RC. So here we are going to take the natural log on both sides to cancel this exponential term. So the minus log of 3 equal to minus t by RC. So the value of log 3 is equal to 1.1. So into R into C. So the equation for the on time, that is T1 equal to 1.1 into RC.